All right, now we're going to talk about the fundamental theorem of calculus. And this is how, like, if you're wanting a summary, this is how integrals and derivatives are related. So there's two parts to this. Part one, if f of x is continuous, and there is some function big F of x where the following is true, where big F of x is equal to the integral from a to x of little f of t dt, then, and this is the fundamental theorem, the derivative of big F of x is equal to little f of x. So in other words, all this is saying is if you integrate a function and then you take the derivative of whatever you got, you get back the original function. Ish. There's some nuance here that we'll get to. But all this is basically saying is the derivative is the opposite of the integral. And the integral is the opposite of the derivative, right? We had f of t, little f. When we integrated it, we got big F. When we took the derivative, we got back to little f. That's the idea here. So let's do a couple examples just to play with that for you. If f of x, or let's write it in a way that you'll typically see it. So the integral of a to x of sine of t dt is equal to big F of x. What is the derivative of big F of x? It's just going to be sine of x. So right, real straightforward. We just basically replace the t with the x. Now, this is a little bit tricky because what if you don't have an x up here? What if you have something else, like the integral from a to 3x squared is sine of t dt equals big F of x. Well, this doesn't work if I don't have x, right? Because the fundamental theorem requires you to be integrating to x. So we can cheat or get around this by let's calling 3x squared equal to w. So we can rewrite this as the integral from a to w of sine of t dt, and that's going to equal f of, well, we can still call it f of x, that's fine. But now when we take the derivative, we're going to take the derivative of, sorry, no, we can't put in that. We have to put in our w. So we're defining some new function like this. Well, now when we take the derivative, we still get this, but we need to realize that w is a function of x, so we need to use the chain rule. So that means we will still get our sine of 3x squared, but then because of the chain rule, we get an extra 6x here at the end. So it's not strictly just plugging in the x into the things. You'll have to look at if you're going to use the chain rule, and there'll be another couple of rules that we talk about later. But that's the idea behind part one. It's just saying if you integrated a function to get a new function, when you take the derivative of that new function, you get back more or less to the original function. The fundamental theorem of calculus part two is the one that we're going to use much more broadly. Part one is useful for some proofs. It's useful to justify some things, but you don't typically use it in calculations. Part two, we do use extensively in calculations. So same setup. If little f of x is a continuous function, and there's some big F of x where it is the integral of little function from a to x, then we know that the integral from a to b of little f of t dt is equal to, sorry, it can be x. Let me rewrite that. F of x dx is going to equal that big antiderivative function of b minus the antiderivative function of a. So this is basically saying if you know that some function is the integral of another function, then if you want to find the definite integral between 2 points, you can just find the antiderivative, plug in those 2 points, and subtract them. It's just saying, since this is an accumulation function of this right here, when we integrate it, just find the total difference of the original. So that's, I know, abstract and kind of general, so let's talk about some examples. So we'll say little f of x is equal to 3x squared. That means big F of x is equal to x cubed. Don't worry about how I got that. We'll talk about the techniques later, but just take it as a given for now that these two functions are related such that big F of x is equal to the integral of little f of x. Then if we want to integrate from, say, 1 to 4 of little f of x dx, that's going to equal to the integral from 1 to 4 of 3x squared dx. Well, that's just going to equal big F of 4 minus big F of 1, which will be 4 to the third minus 1 to the third. 4 to the third is 1664 minus 1, so I believe that's 63, which I think I just wrote under my face. So I believe it's 63. But you can kind of see the idea here of using that antiderivative, or that big F of x, to find the definite integral. So that's the fundamental theorem of calculus part 2. That's going to be, like I said, the main one that you end up using over and over again throughout the unit.